big differentiator for us in our companies. You can do all these things very simply, and that really enables people to do, makes these tools accessible. Right now, if you want to use a drone, you need an operator, someone that really understands what they're doing. For drones to be truly useful tools, it must be able to be used by anyone. So the surveyor with minimal training, or the real estate agent, or even the guy that's inspecting the oil pipeline. You don't specifically want drone people to be doing this. You want this to be just another tool in the tool belt that they already have.
Okay. Thank you for that. So with that, I'd like to open it up to questions from the audience.
Actually, I have a question for Drone Deploy. Do you guys have an API where we can plug into, I guess, your app to be able to interface it with our own applications?
Yeah, so we built.
Could I possibly ask you to repeat the question so that people in the audience can?
Do we have an API so that people can develop on it? So we built our entire platform on the internet. It's designed for these kind of use cases. You can write code in JavaScript and Python, things like that. Let's talk afterwards.
Sorry, I have two questions. I don't know which of you can answer this. One question is related to the issue about UAVs requiring FAA licensing. And I understand that the administration was working to have this done in 2014, but it was not, and it's supposed to happen in 2015. So in order for commercial UAVs to happen, when do you think basically the FAA regulations will be viable? That's one question. The second question is in regards to the drones itself. If somebody wants to fly these drones 24/7, what are some of the power requirements and what one needs to do in order to make this happen?
I'll start with the regulatory, I guess. One of the employees at Aero actually used to work at the FAA, involved in the integration of small UAVs into the national airspace, and he's actually in DC right now, so that's why he's not sitting in this seat. He's probably better qualified than myself. But right, they're supposed to release the small UAS draft rule, which is supposed to come out, let's say, in the next 60 days. But then it's going to be open for comment for a period of time, then it's going to go through changes. So that's a ways out before a rule is going to be deployed across the nation. However, the things that are going on is you can request an exemption from the FAA. It's called the 333 exemption process, where you can make your use case, what are you going to do with it, what kind of vehicle, what the safety and operating procedures are. And so the FAA is granting exemptions right now. So to at least, the industry is pushing a risk-based approach. So if you're going to fly over a farm or over some remote pipelines, the FAA is taking that into consideration versus a heavier vehicle over a populated area, delivering a drone to somebody's house or something. So there have been, I think, 14 exemptions approvals so far, and I found out this morning that the FAA is going to be ramping up. One is the review. I think there's been about 200 exemption requests submitted. The problem up until now was when you submitted something, if you got approved, then you had to, once you got approval, you had to request a certificate of authorization and say, I'm going to fly this vehicle and this piece of property or what you're doing. And so now the FAA is talking about combining the two, so you can get an exemption and the right to fly at the same time. So they're under a lot of pressure from the Small UAS Coalition, from industry to say, come on, jobs are going overseas. The investment's going to start going overseas. Get moving on this. So it's happening.
So going in quickly to the 24/7 type application. So Google's Project Loon, the Titan acquisition, they're focused on that type of thing of very long flight duration. Some of it is sort of possible with kind of the small commercial one, but you need kind of battery recharging and flying a lot, or you need, in general, the fixed wing can fly much longer, an hour plus type in the small form factor versus the small vertical takeoff is like 15-minute flight time. So 24/7, you either need a lot of batteries or battery changing technology like Skycatch is discussing. So there's lots of people working on that type of solutions, but I would say it's not quite polished yet. It's not easy to use today.
Yeah.
Well, one thing I'd like to add to that too, actually, is, so currently, one of the, suggested rules is that you have to be line of sight, and at night, clearly, you're not gonna be able to see the drone once it goes up like about 30 feet in the air. So one of the things that we think will make UAV operations safer is actually by adding a cellular connection so that you can see what's going on in your flight in real time versus someone on the ground who can't see it. So I don't think nighttime flying is actually gonna be allowed at a lower level unless that actually is enacted, because that'll actually make it safer, and or some sort of additional computer vision and object detection software as well.
Okay.
Yeah, and that is the other thing. Right now, even for the hobbyists, non-commercial use, nighttime flight in the US, it's illegal, that's not allowed.
Yeah, one question I had, which other countries outside US, they are more advanced? I mean, where it is going and they are using it in practical, what kind of applications is being used for, and what is the maximum height this should go, and also some kind of traffic control is required. I mean, like we have flight control, somebody has to make sure you don't run into one another, and also security, what kind of, like somebody hacking into the machine and making it do whatever they want.
Can I answer a couple of those? Starting at the height, actually there's drones that go up to 60,000 feet, like a Global Hawk, massive drones. But those are, and then Titan probably beyond that, 90,000 I think. So definitely possible you get drones in all sizes, the size of planes. They're essentially planes without people at the stage. There's a typical drone like you're looking at here would going to go up to about 5,000 feet before they hit problems with just staying aloft with the loss of air density. Talking about the air traffic management, I mean, that's something else. That's why it's useful to have a cellular connection, to be able to tell, you want to have a connection to some sort of internet service that tells you, hey look, these are the other drones in your area, make sure you're avoiding them, or this is the other air traffic. And luckily NASA's working on this problem. There's something called the UTM Airways partner, we're a partner, we're working towards that. How do you actually get all the drones to feed their data into one centralized server that can start making decisions and do the deconfliction? That's happening right now. It's not yet in production that everyone's using it, but that development is being pushed forward by NASA, and we think that the FAA ultimately is also going to basically take the work that they've done.
Just to address your question on the different countries, so France has a risk-based approach. They have 4 scenarios that you can fly under, so it's based on the population you're flying, the weight, the mean takeoff weight of the vehicle, the distance from how far you're going to fly from the operator, and line of sight or altitude is the 4th one. But anyway, so you got the UK, you got France, you got Austria, Australia, Canada. So there's several other countries that have basically aviation rules for how you can fly drones for commercial purposes, and so their businesses are not as much restricted by the airspace requirements. It is by some of the technologies to go to more and more autonomous, so you get the repeatable results over and over, or the whatever kind of sensors that you need to solve the mission at hand.
Just to add to the altitude, sorry, I missed that. These drones generally will be restricted to 400 feet. Generally.
Yeah, so one of the interesting use cases I was thinking about, like drones could be used to photograph any games going on, like a game of cricket, like Australia, there's a game going on. So there are something similar to drone, they have something hanging which the camera moves around. And one of the guy could not catch a ball because it blocked the sight of that fielder. So that kind of use. My question is, so who are making money? I mean, where are people manufacturing are making money, or people selling it, they are making money? I mean, where is the money in this?
Well, we're not making money yet on it, but we want to. Well, actually, we are from a consumer perspective. In fact, we sell quite a bit of consumer drones in our Verizon stores, a lot more than you would think. And Parrot, and from a consumer perspective, I think I was just reading figures. Don't quote me, publicly on this, because I'm just trying to recall off the top of my head. I was just looking at this the other night. I think it was like in 2013, Parrot made $135 million off of its consumer drone business. And 3DR, which is kind of like, oh, I'm sorry, it's not 3DR, it's DJI, which is in second place. It would made $35 million off of just selling consumer drones, the little guys. So those guys are making money, and they have plans to continue to release more drones, and it'll be interesting. Now, from a commercial perspective, it's still very early, and there are some early industries that have been doing some test cases and some actual cases. As she mentioned before, oil and gas industry and pipeline inspection. So I think Aero Environment, got the license to do that up in Alaska. So I'm not sure how much money they're making, but they're probably making a little bit of money. There are a few companies in Australia, because Australia has a lot of big mining industry, and so there are a few companies that are operating in Australia that are making money as well, doing flybys, looking at load management, that sort of thing. So it's starting. And then there are some test trials that are happening outside of America in precision ag as well, and some of the big kind of Wall Street managed farms down in like South America. So they're starting to do some trials down there as well. So the commercial side is just beginning, but I think you guys can imagine how big it possibly could be when some of those large companies start to utilize drones. And also one of the things that's important here, and one of the reasons why Verizon wants to help, is to be able to use a multitude of drones across a wide array of land. You need to be able to scale that. It's hard to have a guy out there with a radio controller controlling each drone. Think about how difficult that is. It'd make a lot more sense to have centralized command and control where you're able to control multiple drones from one location and potentially operate them as well, which is why some of the things these guys are doing are really interesting.
Yeah, one quick question. As an engineer, where do you think we can add, where is the opportunity for engineer, software is, I would presume, the most opportunities, or you feel in the hardware? So what kind of talent you guys are looking, in this field,
Yeah.
which you need to fulfill to reach the targets,
The drone is an extremely complex system. It's mechanical, it basically hits all disciplines from, it's heavy software obviously, but there's physical device, so hardware design as well as mechanical design for the props and everything. So I think it hits kind of all engineering disciplines, but then there's also all the regulatory issues. It's a full gamut. It's a very complex.
No, but I'm an engineer, software, so I would like to see where I can make my next.
I think there's a lot of options. There's a lot of need.
There's even in operations, if you see some of the job descriptions for even things like drone pilots. So even in drone operations in the field, if some of these opportunities open up, you're gonna see a need for those types of skill sets.
Yeah, where we see it real quick, then with another question over here, was we're sort of like the intel inside on the drone, so we have the compliance and the autonomy to fly whatever kind of drone to make it do what you want, but then it's like, on the other end, it's the Apple App Store. So having developers and people, if you understand your business and you know when a seed should start germinating, and if it doesn't, I want to flag all those spots or I need a reseed or something. So the app areas where we see in the commercial side just exploding, just like it did with the cell phones, because people will use a drone to solve who knows what kind of problem.
Yeah, just a follow-up. Is there any open source platform for drone, or everything is closed?
No,
It's different. There's different solutions for different ways. Ours for this the safety critical side, the flight control is a closed, it's being certified in work with NASA and the FAA to be safe. Then on top, the top stack is open for the development. But there's a question, very anxious to ask right there.
I'll interrupt. I like where he's going. Entrepreneurial. So let's say I'm a small business or a large company, right? And I wanted to use your platform and you as an ISP. What is my expected initial cost barrier to entry to allow for such a use case? And then the second follow-up will be, some of the tools, these guys will probably be very important players in terms of insurance, right? Because there's going to be need to kind of make sure everything's running fine. Because, especially with military drones, the failure rate, though largely swept under the rug, is available, and I've kind of worked in that space, is pretty high. So these things will sometimes just drop out of the sky or commit suicide, just because they feel like it. So how does your tech mitigate that? Or does it even mitigate that?
Yeah, definitely. We're very fortunate that every flight that goes in our system gets automatically logged. We know exactly what happens. We know exactly the problems.
Right.
And we showed you a quick pre-flight check there. We do over 50 pre-flight checks. We actually run over once a second on every drone that flies in our system. We give lots of warnings and things like that. We can tell you when the wind is changing direction before it does, because we have access to the internet. That's definitely an important part. Insurers will require that information, talk about faults, tolerance, and things like that. That's going to be a big thing. There are lots of drone companies that say they're reliable, but how do we know which one is more reliable than the next one? At this stage, it's just them saying it. In terms of cost, I think for us as a company, we kind of doing a value-based approach depending on what people want to do. If you're an oil company and you want to inspect oil pipelines, you need a certain quality of service and certain types of data coming back at high resolution, things like that. So we have a different pricing model that goes right from, I'm a simple farmer, I only need simple tools, to the oil and gas stuff, so from hundreds to more.
So let's just say a 10-user drone company, like, you know, most small businesses will be driving a lot of this, not just the major enterprise. What's your cost model, and what will you, as an ISP, be able to provide for them, because they're going to need the downlink?
Well,
Right, well, for us, data, you know, the charges that we have for data wouldn't be any different than it would be that we charge from machine to machines or our cell phone business, so it wouldn't be any different. So you can calculate, yeah, you can calculate based on how much data you're going to be transferring off of your UAV, and then just calculate, you know, how many megabytes or how many gigabytes is it. One of the things that's interesting that's developing in the field, though, is getting, and this is not just for UAVs, but for robotics and for Internet of Things type devices, is how smart can your local processing be versus before you actually send your data into the cloud. And most especially for UAVs, it's really important because the images can be such large files, and there's not, you don't really necessarily need to transfer those large files at that given time. Maybe do a preview of those files so that you can make a smart decision, or you're stitching everything together on the device and sending the final file up, so it's maybe like 10 megs instead of like 10 gigs, right? So I think the way you set up the localization of your processing on your UAV or your device is really important as well.
So my drone will be on my family day of share plan.
So we make things really, really simple for people. We don't want you to have to go to many different people to get your solution. So we actually take care of all those costs. What's interesting is actually talking about the software. There's interesting management problems. For us, we have massive servers. It doesn't matter how much data they get. Obviously, we want to transfer it, but luckily the price of data is becoming cheaper. It's the most expensive right now that it will ever be. And that's a good thing for us, obviously. So the cost of the data are actually relatively smaller than some of the other costs that you would have to incur, like the cost of the drone and things like that.
All right. So can we quote him on you saying that this is how expensive it's going to be? And then how about the mitigation of failure rates?
I'll address that one. When I'm talking to underwriters as well as the aviation authorities, so they look at it in several different ways. One, you always hear about the pilot. Should it be a certified or manned aircraft pilot and all that? And that's changing to where if I have a completely autonomous 3-pound vehicle flying over a peanut field, I don't need to have a manned, Harrier jet pilot to do that. But there's a pilot, some sort of pilot certification based on the mission that you're doing. The aircraft itself, what sort of airworthiness does it have? And it's not only initially what was the airworthiness of that vehicle, what's the state of the aircraft? And so being able to know that if you're an insurance company, Progressive or somebody, you insured this vehicle configuration, that somebody hasn't, the do-it-yourselfers haven't monkeyed around with it. So that's a way to have an electronic ID that this vehicle is the same, and after my 50-point checklist, it's still valid. And then the mission itself, so is it geofenced to within the policy that you have signed up for, so it'll only fly in this area to this altitude, so you can fly however you want in this box, But that's, if you're a commercial entity, you say, hey, look, I want a policy for right here, that's where it's gonna work. So the little kid can't take it and fly around in New York City or in the fireworks or something, it only flies there. So you have the person, the vehicle, the mission, and then the data. So how is the data encrypted, it can't be spoofed, and all this other stuff. So the data security is another issue because they can get in trouble with privacy or flew over somebody's house or something.
Okay, so bundle with my family plan, bundle with my car insurance. Got it.
Yeah.
I have a question here. Can you please explain at the technology level, what is the best way, I mean, the current optimal way to combine the both software and the hardware technology to ensure the accuracy of the data analysis of the streaming data in the real-time manner? I think maybe currently we rely more on the software processing, especially we rely on the machine learning algorithms. But can you please explain if there is a trend that maybe we are going to enhance further the hardware, or we are going to still rely on the stronger software algorithm to ensure the data accuracy and also enhance the performance of our data processing?
Yeah, I mean, I think on the drone side, the cost is coming way down. You know, these little ones are at $300, $400, something that would cost, you know, tens of thousands, you know, just 2-3 years ago. And so on the drone side and the collection, you know, going and getting the data, the cost is coming way down. And then,
And I was gonna say the technology in that is very advanced.
yeah, that's the other piece, is that these little tiny drones, because there is such a large market for just kind of the quote consumer and the fun, is, you know, it has sonar, it has a downward facing camera, it has this gimbal that's all digital, so it's years of software, hardware development for these solutions, and it's just available at your local Verizon store that anyone can go pick it up. And then as far as the data analysis, that's your end.
Yeah. We're in Silicon Valley. We know that software is going to eat the world. I mean, that's the bottom line. So the hardware is getting better, but it's incremental. We've already done the 0 to 1 in the hardware. We already have quadcopters. And next year they'll fly for 10% longer. That's great. Next year they'll have 10% more megapixels. But the software is where things are really happening. That you can get the 10x improvements and the 10x improvements in speed, or the 100x improvements in speed and quality and things like that. And you talked about machine learning, and those disciplines are only now being applied to the data from drones. And that's what's quite an exciting time for us in the software industry. How can you apply all the things all the open source technology that is being created in the last 10 years, all the web technologies, all the machine learning algorithms to the data that we're getting off drones, and potentially do it in real time, because we can get all the data off that drone into the cloud as it's happening.
So one of the things that we've been working on a lot is how to leverage this data in the cloud, how to cross-correlate it with other data that you can get from other sensors, as well as how to process some of the data that you're getting in the cloud in order to be able to generate some insights. Now, all of this processing from an analytics perspective, from a very higher level analytics perspective, is leveraging all of the technologies that we're getting from the big data community, from the machine learning community, from the image processing and video processing communities, who in the past have been working with CCTV type data, for example. However, having said that, I actually see an opportunity in the future where some of this processing that's occurring in the cloud will get pushed to the edge, and we will be able to see the drone and its various hardware extensions as a vehicle to do some of that processing on the drone itself, and then generate insights that are then taken back into the cloud. So there will be a different distribution model as we get more sophisticated in this balance.
How many startups have come up with the $250 million that has been pumped into the market last year? And out of those, like, how many startups have popped up in Silicon Valley? If Silicon Valley is not the major hub for innovation, which other cities coming up with more startups? And the other question I have is testing. Where exactly? So I think, like, if startups come in metros, I think testing is a key part. Like, where do you see testing hubs will pop up? And the third, if you can answer, like security.
Well, in the data that I pulled was actually from PitchBook. So it was in, you know, and I did a search of UAV and keywords for UAV and drones. So I don't know exactly how many companies were startups within that. But there are some stats. What I did look up was in AngelList. I think there is currently over 100 companies, UAV companies, listed in AngelList right now. So I don't know how many of those are in the Bay Area. So Brian might know because he manages the most popular meetup for UAVs. So maybe I'm better.
Yes, we have about 1,200 members. That is the SF Drone Startup Meetup Group, and it is a bunch of people that are in the space, that are in startups. There's also people who are not in startups that are interested in getting into them. But it is, you know, we have attendance around, you know, 100 people every time. So it is quickly growing, and it's just the meetup group is only 2 years old. So it is grown from 0 to 1,200 in just 2 years. So it is growing quickly, and there is, I think, a lot of companies in Silicon Valley. There's the Dakotas. There's some strong state emphasis for the drones, but a lot is in Silicon Valley.
I think the cost of entry for some of the work is really low. If you can buy $1,000 drone, and if you're a software developer, all of a sudden you could have 3 guys. Actually, the Skydio that mentioned these guys, they worked at Google X together a couple of years. They came out of MIT. I think it was 3 guys. They just got $3.5 million from Andreessen Horowitz for that technology. You saw the plane flying around through the parking garage. So it's you know, the software eats the world. I mean, you could have a very low cost of entry to create some pretty amazing technology.
So do you have somebody from Drone Deploy here? I just found your name there. I mean, Drone Deploy, and also Ghost. I mean, what's your, how is the Ghost drone that is fully,
Yeah, there's lots of different hardware manufacturers coming out. Ghost Drone they make quadcopters or hexacopters. They'll be competing with guys like DJI.
There's knockoffs of the knockoffs of the knockoffs for the consumer
Yeah.
space. I mean, I think that the hardware in general is just going crazy, but when it's very specific for commercial applications or robustness or something, the commercial side that we're looking at, let's say there's 600 of them,
Yeah.
those may be 3 or 4 man operations to publicly traded companies, you know, in Europe. But it's really what is it doing, what data is it capturing, how is it going to, you know, what services are being provided. So
It really depends on the use case and what you're trying to accomplish in you know, wading through the mass of vendors and trying to figure out, you know, the right bird for the right job.
yeah, I mean, where do you see in the future, Amazon was trying to deliver your goods using drone. Do you see in the next 5 years that happening?
There's definitely going to be some delivery of some scenarios where that's happening. We'll start with things like medical delivery and things like that, maybe do business next, and maybe it's potentially from, I don't know, warehouse to warehouse. But it's coming.
DHL just announced a very, very small experiment delivering goods to an island just off of Germany. But that's just one data point, and it's an example of a trend that it's coming. It's just a case of how long before it will come. I think there's a question here on this side.
So on the more practical side, drones have very short, at least on this 5-pound scale that you're working on, have very short flight times. So they effective return ranges of, say, 30 miles. So when you're doing something like pipeline analysis or scanning of thousands of miles that you want over and over, beyond the advancement of batteries, which nobody's sort of talked about here or sort of in that space, where do you see the improvements? I mean, somebody had mentioned the long-lasting planes, which you'll get about 12 hours with if you put solar panels on, but those are slower flying. Those are sort of 20-mile-an-hour planes. You're still talking about 80, 100 mile an hour, 80 or 100 mile effective radiuses. So you need a lot of individual stations. Fine if you're doing a farm, but pipelines. Any thoughts on that or directions there?
Well,
no one said it's limited to just electric drones, right? There are gas-powered drones as well, that the military uses that can stay up in the air for, 24 hours, for example. So if you're flying out in like Alaska, checking out a 80-mile pipeline, you might want to pick one of those guys up. But there are people that are innovating that particular concept. That one of these guys here mentioned Skycatch as well, where you can have a battery replacement, an automated battery replacement system. That's one way. Using solar film on the panels for the daytime usage is also another way to get that done. But
Yeah, they're also, you're gonna see a lot more advances in aerospace design now because of this, so it's actually developing faster than it has in the past. So there's already transitional VTOLs, like a vehicle that takes off like a helicopter and transitions and can fly longer distances, but I think the number of commercial applications, let's say a cell tower, there's 1 million cell towers that get inspected with people climbing up and down with ropes and getting struck by lightning or falling off and spend a lot of money in the cell. Here's one right here. There's people pretty much visiting a cell tower once a month to do something, and different people are hanging things off. And you could, in 30 minutes with one drone flight, you can get a lot of information that's valuable to a number of stakeholders on something like that. Or, power line, high voltage line poles and stuff. So there's a lot of value in the very short term versus I gotta figure out how to fly 1,000 miles at one stop.
Absolutely, I think there's low-hanging fruit, which is going to basically open up the market, get that revenue flowing, which in turn will translate into investments made to solve some of the harder problems.
It's funny, we almost take that completely opposing direction on this. We don't think it really matters. We're only going to get incremental improvements from here. These drones can already fly for 25 minutes. If you've got a plane, you can do an hour. But actually, how long do these things really need to fly? Right now, the rule of thumb is that for every minute of flight, you're going to have at least 5 minutes of actual data processing and dealing with the drone. And that's where the opportunity is to capture that value. Rather have several drones, have many drones along the way. That's actually a much better approach than having one long distance drone that has lots of operational procedures and runways. And if it falls out the sky, then you've actually killed people or have lost hundreds of thousands of dollars versus having many small drones. It's like kind of a personal computer versus a mainframe argument.
one interesting solution I've seen, I haven't seen it in action yet, I've just seen kind of plans for it, is imagine a big field, a farming field, right? And currently there are scarecrows and there are other things that farmers put in the field to activate the tools that they have in those fields. So imagine having pods in those fields that are solar panels that the drones actually land in like little birds' nests, right? And they sit there and they get charged up all day long, and then, like at night they go flying around because they're all charged up from the day. So if you have those strategically over your acres of farm, it really wouldn't matter. And to these guys' points, a lot of the drone use cases happen in the first few minutes anyhow. Because once you take that image, it's a huge, swath of land that image is happening already. So.
How do you avoid collisions between drones, especially the drones who are manufactured by different vendors? Are there any standards or the protocols where different drones communicate with each other?
I mean, right now, just a real life case. So in France, if you're gonna go use a drone to survey a quarry or a mine for volumetric analysis, so the drone operator submits his plan, this is the GPS coordinates, or where I'm gonna fly it tomorrow, and this is my box, and so now they're approved to fly in that area, so there's no other drones gonna be flying in that area. There's a lot of airspace, and there's some calculation, I looked up on Google or something, it's like, the chances, I think this is the Amazon guy said this, the chances of drones hitting each other in the sky in three-dimensional space, there's gotta be a ton of them flying around before that's the case. But right now it's more regulated, so.
If they have to deliver this, more drones will be flying in the air.
Yeah, but it's with the cellular connectivity, triangulation off the towers, you've got GPS, you have sonar, you have all these technologies, transponders. There's transponders that are using manned aircraft now that are coming down to small size that can be put on a drone. It's going to basically beacon it's who it is and where it is.
So there are sense and avoid approaches that you can in fact take with drones. However, those are expensive right now, and those price points have to get reasonable. In the interim, essentially most of the regulatory bodies are taking a COA type approach where you do have to register your flight plan and get approval in order to be able to fly. And that's an interim solution that, that should hold for some period of time.
Yeah, and if you want to get some money to figure that sense and avoid outsource, DARPA has a solicitation out right now. You can get $5.5 million, and they'll basically give you the drone that you're going to fly on. You have to produce the algorithm to do basically a high-speed flight through like a forest. You think of the Jedi scenes in Star Wars, and so we're involved with one of the companies involved in that. But they're wanting to figure out GPS denied, high speed through congested area flight. So our government's looking at that at the very least.
So has there been any thoughts in terms of solving the border security problem using drones?
Oh, the border security.
Yeah, I believe there's actually 2 predators flying over the border right now. Definitely being used. But these drones in the military sense are a little bit different from drones in the commercial sense.
Yeah.
Drones, they'll call them remotely piloted vehicle. They've still got a cockpit somewhere in Nevada, and there's still at least 2 guys piloting that vehicle. In fact, sometimes for most drones, there'll be internal pilots and external pilots, equal to fly the drone when it's flying the border and equal to land the drone when it comes back. It's definitely already being used.
Yeah, I would say the Department of Homeland Security is using either hand-me-down military drones or straight military purchases for doing that. The Department of Interior, which manages the land for like forest fires and land management, they're getting hand-me-down from the military, but they're tired of it because they're too expensive. They're expensive to maintain. They're not flexible to add these new cameras and things. So we're talking to them about re-outfitting them with different flight controls to do some pretty important work for the U.S.
I just heard of a case, a border security type situation where not drones, but robots were actually deployed in the field. And I almost did a double take when I heard that, but because it was a very, very interesting case of use of robots, almost like, what do you call it, you have the dog brigade that goes into comfort as people who have gone through some sort of traumatic situation. Well,